All right, this problem is from section 1.6, problem number 48. It gives us a graph and it says the function of g of x equals 3.6 radical x plus 24.3 models the median height, g of x, in inches of children who are x months of age. The graph of g is shown here to the right. Part A, it says describe how the graph can be obtained using transformations of the square root function f of x equals radical x. All right, so first off, f of x equals radical x is called a parent function because it doesn't have any transformations, and it would have this same shape, except it would start here at 0. Now, there's two numbers that are affecting this parent function radical x. One of them is this 3.6 and the other one is this 24.3. Notice that the 24.3 is being added to the radical x, but the 24.3 is not inside the radical. So when you add a number and it is not inside the radical, it causes the graph to move vertically. This is a positive number, so the graph will move up 24.3 units. Therefore, since the graph is going to move up 24.3 units, remember we said it was going to start here, but now it's going to move up 24.3 units, we know that the answer can only be choice C, because C is the only one that shows us that the graph moves up 24.3 units. So let me press enter there, and of course it says that's the correct answer. Now, the 3.6 does affect the graph also, and how it affects it is by vertically stretching it by a factor of 3.6. However, we knew that C was the only answer choice because that was the only one that offered us an answer of the graph moving up 24.3 units. All right, let me get the calculator back up here for this second part. Now, the second part says, according to the model, what is the median height of children who are 48 months or 4 years old? Use a calculator to find the median height. The median height is blank inches, round to the nearest tenth of an inch. So what we're simply going to do is take the number 48 and plug it into this function here. So I'm going to type it in, 3.6, and I'm going to press second now and press x squared, and that's going to give me a square root. On your calculator, it may look slightly different because I have an updated operating system on mine, but you'll still type the numbers in the same. You may get a parentheses. If you do get a parentheses, make sure that when you type in this 48, you close that parentheses. I'm simply going to move out of mine, and I'm going to type plus 24.3, press enter, and it gives us 49.24153 and so on. However, it said round to the nearest tenth of an inch, so in order to do that, I would just knock off every number after the 2, round down to 49.2, and let's see if that is correct. So 49.2, excellent. All right, now the second part of the question says the actual median height for children at 48 months is 49 inches. How well does the model describe the actual height? So we got an answer of 49.2, and the answer is supposed to be 49. So those numbers are extremely close to each other, only off by 0.2. So I'm going to say the model describes it very well. All right, if we would have gotten something like 55, then hey, there's something that's a little wrong with that. However, the 49.2 is great. Okay, let's move on to the next one. Now, all right, part C, it says use the model to find the average rate of change in inches per month between birth and 12 months. All right, we're going to continue this problem over here. So once again, I'll read it. Use the model to find the average rate of change in inches per month between birth and 12 months. Average rate of change is the same thing as slope. Now, if you recall, the slope formula is m equals y2 minus y1 over x2 minus x1. So what we need are an x1 and a y1, and we also need an x2 and a y2. So let's go back to our formula here for a second. Remember, the formula is 3.6 radical x plus 24.3. All right, so let's see here. So 3.6 radical x plus 24.3. Now, they actually give us two x's. It says between birth and 12 months. This 12 months is going to serve as x2. Birth, which is 0 months, so 0 is going to serve as my x1. So I have x1 and x2. What I now need are y1 and y2. So let's find y1. In order to find y1, what I would do is f of 0. I think, let's see. Okay, it's called g, which is not a big deal. Let's erase that. So let's do g of 0. So do g of 0. I would do 3.6. Oops. Okay, 3.6 times the square root of 0 plus 24.3. Now I actually don't need the calculator for this because this whole thing is going to become 0 and I'm just going to be left with 24.3. So my y1 is 24.3. Now I have to get y2. In order to get y2, I have to do g of, we have to plug in this number 12. So g of 12, and that's going to be 3.6 times radical 12 plus 24.3. Now for this one we will use the calculator, so let's bring that up here and let's type in 3.6 square root 12 plus 24.3. Alright, and that gives us 36.77, so let's round that to 36.8. Alright. 36.8. 36.8 is my y2. So what I'm going to do now is plug in y2, which we just said is 36.8, minus y1, which we found to be 24.3, divided by x2, which is 12, minus x1, which is 0. Alright, and we're going to need our calculator once again. Alright, let's type that into the calculator. Now, when you are using your calculator to find this, you always have to make sure you use parentheses. A lot of times when people have mistakes using a calculator, it's, unfortunately you that made the mistake, because the calculator is simply going to do whatever you tell it to do. So I'm going to use parentheses on the top. So parentheses 36.8 minus 24.3, close parentheses, divided by, now 12 minus 0, I can just put 12. 12. Enter, and that gets us 1.041. Alright, let's go back here. So 1.041, let's pull this up once again. So it says round to the nearest tenth. If we round that to the nearest tenth, we would actually put in a 1. And let's see. So we get a well done there. Alright, now it says use the model to find the average rate of change in inches per month between 40 and 52 months. Alright, so we're back here, and once again it asks us to find the average rate of change in inches per month between 40 and 52 months. So remember that average rate of change is the slope. So once again, m equals y2 minus y1 over x2 minus x1. Now I'm going to just plug in a couple of the numbers here first because we've done a similar problem to this. 40 is x1 and 52 is x2. So on the bottom here, I'm going to type in 52 minus 40. Now, once again, we have to get y2 and y1. And recall, to get those, we use the calculator. So I'm going to do this kind of quickly here. All right, so let's do 3.6 square root 52 plus 24.3. Okay, so we get 50.2599 and change. Let's round that to 50.3. Now that is our y2. So I'm going to write that in for y2. Let's see what that was again. That was 50.3. Minus what we need now is y1. And to get y1, we're going to do 3.6 square root 40 plus 24.3. And that gives us 47.068 and change. That rounds to 47.1. All right, let's write that in. 47.1 is our y1. All right, now the last step is to plug this whole thing into the calculator. Remember that we're going to use parentheses. So 50.3 minus 47.1, close parentheses, divided by, we can figure out what 52 minus 40 is in our heads, but let's just say it was a bigger number. And I'm going to use parentheses once again on the bottom. Press enter, and we get 0.2666, and it keeps repeating. So to round that to the nearest tenth would give us 0.3. All right, and let's type that in and see if that is correct. All right. The last part says, how does this compare with your answer in part C? How is this difference shown by the graph? All right, now our average rate of change in part D is smaller than our average rate of change in part C. So the answer can only be either B or C. And if you notice, what the graph starts to do is level off. So being that it's starting to level off, it is not as steep. So our answer has to be choice B, and that is correct.